Good morning. Welcome to Function Focus Home Learning Lesson 3. We were previously in the second unit and we were focusing on graphing linear inequalities. We have moved on now to Unit 3.2, Systems of Equations. Our objective is hopefully by the end of this lesson, you'll be able to solve systems of linear equations algebraically using the substitution method. We have 3 activities. Activity 1 is the notes, which is in the email. Activity 2, which is the tricky problems, which is also in your email. And then the individual practice, which I will go over what my expectations are, and hopefully you'll take the opportunity to practice those skills. I did give you an assignment last class. Okay. I'm going to post this here. I want you to take this time to pause your screen and look at these answers. If you do not understand or are confused about anything in these answers that I have here, please do not hesitate to email or comment on my YouTube. Okay. Right. Now, what we're doing today. Again, we're talking about graphing linear inequalities. We're talking about solving systems of equations algebraically using the substitution method. Okay. First things first, what is a system of equations? A system of equations is just more than one equation. It has to be more than one in order to be a system. So it could be 2, it could be 5, it could be 6. But the thing here is it's only a system if there is a solution for all of the equations. So for example, we have here an equation 3x plus 4y equals -4, and we have the equation x plus 3y equals 2. This is a system. It's more than one equation. The question here is, could the solution be 0, 1? So could the solution for this system be 0, 1? And how we find that is we plug 0, 1, where the x term is 0 and the y term is 1. We plug them into each of these and figure out if it works. Okay, so we have 3 times 0 plus 4 times 1 equals -4. Okay, well, 3 times 0 is 0, and 4 times 1 is 4. So we have 4 equals -4. Is that true or false? That's false. Okay, so this point does not work for this equation 3x plus 4y equals -4. I can stop there. In the beginning, I said you have to plug in the point into both, but if it does not work for one, then it doesn't matter because it cannot be a solution to the system because it must work for both. So because it did not work for the first equation, I do not need to plug it into the second equation because I know that the point 0, 1 is not a solution to this system. So the key here is to remember that the solution must work for both equations. Okay, it must work for both equations. All right, now the substitution method of solving systems of equations algebraically. The goal. What's the goal of the substitution method? The goal is to solve the system when one or both equations are already solved for a variable x or y. The solution point is xy. So let's look at here. There are 3 steps. The first step is to solve one, and this should say function or equation. Solve one equation for x or y if it's not already done. Okay, if you look at our example here, we have y equals 4x plus 3, and we have y equals negative x minus 2. Step 1 is already done for us. Both of these equations are already solved for y. Okay, so that's what's meant by that first step. Solve one or both of them for y or x. Okay, all right. Now, once that's done, substitute one equation into the other. Okay, so step 1 here, y equals 4x plus 3, and we have y equals negative x minus 2. Step 2 says substitute one equation into the other and solve for the first variable. So I have two equations in here. I'm going to take my y equals negative x minus 2, and I'm going to substitute it in for this y. Remember, it says y equals this. So y is this, y is this. They are the same. So wherever I see y, I can plug in negative x minus 2. So I have y minus 4x plus 3. Now I'm going to take this and I'm going to plug it in here for y. So it's become negative x minus 2 equals 4x plus 3. Okay. So what I did just now is I plugged in this negative x minus 2. I plugged it in for y. So then it becomes negative x minus 2 equals 4x plus 3. Okay. Make sure you understand that. All I did was, if y is equal to negative x minus 2, then I can substitute negative x minus 2 for y. That's why it's called the substitution method. Now I'm going to solve. It says substitute one equation into the other and solve for the first variable. So the only variable that's left here, as you can see, is x. So I'm going to solve for x by doing inverse operations. So I want to get x by itself. So I'm going to combine my x's and I'm going to combine my constant terms. So now I'm going to combine my x's by adding x. The x on the left is negative. I'm going to add it to both sides. That gives me negative 2 on the left side. On the right side, I get 4x plus x is 5x plus 3. Now I'm going to get my two constant terms together. So I'm going to subtract 3 on both sides. That's going to give me negative 5 equals 5x. Divide by 5 on both sides. X is going to be equal to negative 1, because negative 5 divided by 5 is negative 1. So I've now solved for my first variable. Okay. So now I know what my x term is. I know what my x and my point is going to be for my solution. Step 3 says plug your answer into one of the equations to find the second variable. I found my x value. Now I'm going to plug this x value into one of these equations. Doesn't have to be both. It just has to be one. So it is, let's choose, I'm going to choose the first one. So I have y equals 4x plus 3. So now I'm going to take this x and I'm going to plug it in here. So I get y equals 4 times negative 1 plus 3. Therefore, y equals, well, 4 times negative 1 is negative 4 plus 3. Y is negative 1. Okay. Because negative 4 plus 3 is negative 1. Now, I have my point. This is my answer. My answer to the solution to this system is negative 1, because x is negative 1, comma, negative 1. That is my solution. Okay. Okay. Now, don't forget to check your solution. don't forget to check your solution. All right. Let's check it here. We're saying that my solution, -1 and -1, is the solution to this system. Y equals 4x plus 3. Y equals -x minus 2. So I'm going to plug in -1, -1 to find out if that is true. So -1, this is the first one, -1 equals 4 times -1 plus 3. -1 equals, well, 4 times -1 is -4 plus 3. Well, -4 plus 3 is -1. -1 equals -1. Great, it works for the first equation. Let's look at the next one. This one I'm talking about. -1 equals -1 because it's -x and x is -1 minus 2. -1 equals -1 times -1 is +1 minus 2. Okay, and then 1 minus 2 is -1. So it works for both. So therefore, our solution that we calculated using the substitution method, -1 times, -1 comma -1, is a solution to both of these equations. Therefore, is a solution to the system. Okay. Next up. Now, if we were trying to, now we can also solve this graphically by just graphing each of the equations individually and figuring out where they intersect, because where they intersect or where they cross is the solution. So let's look. Y equals 4x plus 3. Well, my slope here is 4/1, and my y-intercept is 3. So now I'm going to go start with my y-intercept, and you guys already know how to do this. I'm going to go to 3, and I'm going to go up 4 and over 1 because the slope is +4 over +1. So 1, 2, 3, 4, and then 1. Now notice on this coordinate plane, they're counting by 2s. So 1 is in between 0 and 2, and 3 was in between 2 and 4. Okay. And then I'm going to graph it. Okay. And this is the line y is equal to 4x plus 3. I'm going to do the same for the second one. Y equals -x minus 2. My slope here is -1 over 1. And my intercept is -2. So I'm going to go to -2. And I'm going to go down 1 to the right 1. I'm going to do it again. Down 1 to the right 1. Okay. And I'm going to connect my dots. Okay. And this is the line y equals -x minus 2. Now remember I said where they intersect is the solution. Well, they intersect right here. Okay? They intersect right here, and this is the point this is the solution, -1 and -1. So we can, this is another way we can prove that what we calculated when we did the substitution method, we can prove that that's true by also graphing it. But you don't always have access to a graph. So it's best to just check your answer using by plugging in your solution to both equations. Let's do it again. So solve this system using substitution. Step 1, if you look back at your first page, says solve one or both of the equations for y if not already. You really just need to solve one. So neither one of these are already solved for y. So I'm going to solve the second one for y. Actually, I'm going to solve the first one. This will be easier to solve for y. Okay, so I have 3x, so choose one, 3x minus y equals 13. By the way, you could have chosen the second one. Whichever one it looks easier for you to solve for y, that's the one you should choose. Okay, so I want to get y by itself. I need to get rid of this 3x. I'm going to subtract 3x because it was already positive. In order to get rid of it, I have to subtract it on both sides. It's just like making it into slope-intercept form. Then I have negative y is equal to negative 3x plus 13. Okay. Well, negative y is not y. I want to get rid of this negative. So I'm going to divide by negative 1 because that's all there is. There is negative 1. That means I have to divide everything by negative 1. And I get y is equal to negative 3x divided by negative 1 is just positive 3x. And then 13 but divided by negative 1 is negative 13. So that's my first step. I just solved one of them for y. Now my second step, if you look at your first page of notes, says substitute one of the equations into the other and solve for the first variable. So whichever one you solved y for, you're now going to plug this in, this 3x minus 13, you're going to plug this into the other equation. So it's 2x plus 2y equals a negative 10. Well, I said that y is equal to 3x minus 13, so where I see y, I'm going to plug it in here. So this y is going to now become 3x minus 13. 2x plus 2 times 3x minus 13 is equal to negative 10. All I did was I plugged in this 3x minus 13 into the other equation for y. And I'm going to solve for x now because x is the only variable we have left. So now I'm going to distribute my 2. This becomes 2x plus 2 times 3x is 6x. 2 times negative 13 is negative 26 equals negative 10. All I did was distribute. Now I can combine like terms. I have 6x and 2x, which becomes 8x minus 26 equals negative 10. And I'm sorry it's on a slant, ladies and gentlemen, but that's how I have to write because that's how I'm positioned with the tripod. Okay. All right. Now I want to get rid of I want to get 8x by itself. I'm going to add 26 on both sides. That's going to give me 8x equals 16 divided by 8. X equals 2. Okay. Now, the distributive property and combining like terms is all skills that you guys learned in Algebra 1. Okay, so I'm not going to review those skills because that's something we should already know. If you are confused about what I just did, just run the video back and then watch it again. Okay. Now, the third step says plug in your first variable, whatever you solve for first. Plug that into one of the equations to find the other variable. So I'm going to plug in this x into one of these equations to find my y. Okay, so I'm going to plug it into the first one. So I have 3x minus y equals 13. I'm plugging in my x. I'm substituting x for 2. This is exactly why they call it the substitution method again. We substituted in step 2. We're going to substitute again in step 3. So that becomes this becomes 3 times 2 minus y equals 13. 3 times 2 is 6 minus y equals 13. I want to get y by itself. I'm going to subtract 6. It's positive 6. I want to move it, so I have to subtract it on both sides. This gives me negative y is equal to 7, because 13 minus 6 is 7. But I don't want negative y. I want y, so I'm going to divide by negative 1 on both sides. Therefore, my y is equal to negative 7. Excuse me. So now I'm saying my solution is the point 2, negative 7. So I'm going to plug in this solution into both of these to check it. So let's check. Okay. Check 2, negative 7. So plug it into the first equation. 3 times 2 minus negative 7 is equal to 13. So 3 times 2 is 6, and then negative 1 times negative 7 is positive 7 is equal to 13. Well, that's true. 6 plus 7 is 13, so 13 is equal to 13. That's how you know that your answer, when you check it, is correct. Is this a true statement? If it is true, then you know that it's correct. Okay, next up is the next equation. So 2 times 2 plus 2 times negative 7 equals negative 10. So here I have 4. Now 2 times 2 is 4, and 2 times negative 7 is negative 14 equals negative 10. Well, 4 minus 14 is negative 10. So negative 10 equals negative 10. And our solution works for both. Therefore, it is a solution to the system. Very important here. If you get something like 11 equals 13 when you check it, if you get something like when you check it, or if when you're substituting you get something like 5 equals 10, these are false statements. These are false statements. If you get false statements, then it means that there is no solution. Okay. If you get solutions like 0 equals 0 when you're substituting, if you get 5 equals 5, okay, then that means that there are infinite solutions. It's a true statement. And I'm going to show you what I mean in a moment. Okay? So you can either get one solution, you can get no solutions, or you can get infinite solutions. And let me show you what I mean. So sometimes something's going to seem wrong. Doesn't mean your calculations are incorrect. It just means that there's a possibility that there's no solutions or that there are infinite solutions. Let me give you an example. Step 1. Again, step 1 says to solve for y or x. Solve one of the equations for y or x. I'm going to choose the second equation here because it looks like y is already almost by itself. So I only have one step to do. So negative 2x plus y is equal to 1. I want to get that y by itself. I'm going to add 2x on both sides. Okay. That gives me y is equal to 2x plus 1. Bam. So I've completed step 1. Now I'm going to take this 2x plus 1 and I'm going to plug it into the other equation where I see y, because it says y equals 2x plus 1, so I'm going to plug it in. So negative 4x plus 2y equals 2. This y is now going to become 2x plus 1. Negative 4x plus 2 times 2x plus 1 is equal to 2. Okay. All I did was plug it in. I rewrote it. Now I'm going to distribute my 2. I get negative 4x plus 4x plus 2, I'm sorry. Right, because 2 times 1 is 2, equals 2. Now I'm going to combine my like terms. Negative 4x and 4x makes 0. Plus 2 equals 2. And now I have 2 equals 2. Hey, I didn't get an x equals. I got a 2 equals 2. When you see this, like I said before, when you're substituting, you see 2 equals 2. This is a true statement. This is a true statement. That means that there are infinite solutions. This is your answer here, infinite solutions, because this, when you substitute it, it gave you a true statement. It means that these two equations are basically equal to each other. They are the same equation. If I was to solve this one for y, I would get the same equation out. Y equals 2x plus 1. And since they are the same line, they overlap. Okay, they overlap. The lines overlap like this. Therefore, they're all the same point. So it's infinite solutions. Okay. Let's solve this system. I have 3x plus y equals 1, and I have 6x plus 2 equals negative 10. I'm going to solve for my first step, which says to solve one of them for y. I'm going to solve the first one because it looks like it's easier. I have 3x plus y is equal to 1. I'm going to get rid of this 3x by subtracting it on both sides. Therefore, y equals negative 3x plus 1. I'm now going to step 2, take this negative 3x plus 1 and plug it in for y in the other equation. 6x plus 2y equals negative 10. I'm going to take that negative 3x plus 1 and put it in for y. 6x plus 2 times negative 3x plus 1 equals 10, negative 10. Okay, do my distribution. 6x plus, 6x minus 6y, 6x minus 6x, sorry y'all, because 2 times negative 3x is negative 6x, and then 2 times 1 is 2 equals negative 10. Okay, so now if you see 6x minus 6x, when I combine my like terms, is 0, right? Plus 2 equals negative 10. Well, 0 plus 2 is 2 equals negative 10. This is a false statement. 2 does not equal negative 10. Therefore, because I got a false statement when I did my substitution, this means that there's no solutions. It means that the lines never intersect. They never overlap. Okay. Right? Okay, now for your individual work, I give you 4 problems. 4 problems to work on. Okay. Again, use all your steps. I've broken it down for you. Use all your steps. Don't forget to check your answers. And then remember that they might not always have a solution, and they can possibly have infinite solutions. So don't get tripped up if when you're substituting, it gives you a false or true statement, such as the ones we just did before. Again, I hope everyone is staying happy and healthy, and I will see you on Wednesday for our next lesson. Bye.